There are 2 points. One is rear point and the front point. Rear is a point where insertion takes place and front is the point or a pointer, the elements to be deleted. DQ is nothing but to delete an element from the queue or to remove the element. Whenever you say front equals to front plus 1, that is the logic to remove the data item at the index front. Dear students, welcome to computer science classes. I am Ravi Kumar K.R., lecturer in computer science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, today let us start our discussion with the concept or the topics operations on queue. In our previous session, we have discussed about the definition of queue and different types of queue. So what is a queue? Queue is a data structure where the insertion and deletion takes place at 2 different points and it follows the principle of FIFO, that is first in, first out. Now let us see what are the different operations can be performed on queue. The first operation, that is queue. Here it creates a new queue that is empty. It needs no parameters and returns an empty queue. So in order to start working with queue, first step is we have to create a queue. So this is a function. So this is an operation. It is first we have to create a queue with the operation queue. And next one is NQ in the bracket item. It is the parameter. It adds a new item to the rear of the queue. It needs the item and returns nothing. This operation is generally called as push operation. And here, next is NQ in the bracket item. So this is nothing but to insert a data item to the queue at the rear point. We know that we have learned there are 2 points. One is rear point and the front point. Rear is a point where insertion takes place and front is the point or a pointer, the elements to be deleted. So accordingly, a new element, the item is the new element, is inserted at the rear point. So the function or the operation is NQ. Next operation is DQ. It removes the front item from the queue. It needs no parameters and returns item. The queue is modified. This operation is generally called as pop operation. DQ is nothing but to delete an element from the queue or to remove the element. And we know that deletion takes place at the front point or front pointer. So DQ is an operation to remove elements at the front point or front pointer. Next operation is empty. It is a function or operation. It tests to say whether the queue is empty. It needs no parameters and returns a Boolean value. Here Boolean values are, you know that 0 and 1. It returns either 0 or 1 and isEmpty is a function. It checks for whether the queue is empty or not. Next one is size. It returns a number of items in the queue. It needs no parameters and returns an integer value. So size, if you use the function size, it returns the number of elements in a queue. Now let us move on to next slide. Here, memory representation of a queue using arrays. Here, we are implementing queues using arrays, single dimensional array. Now let us see how we can represent in computer memory through arrays. Queue is represented in memory in a linear array. Let Q be a linear queue. So this is the name of the queue. QUE. It is a queue, name of the queue. And the pointer variable front. Front is the pointer. It contains the location of the element to be removed. Already we have learned the definition. And the pointer variable rear contains the location of the last element is inserted. And the condition front equals to null indicates that the queue is empty. Here, as what you have learned in our previous session, here there are 2 pointers, front and rear. If front is pointing to null, is it indicates that queue is empty. There are no more elements. So we cannot remove any element from the queue. So this is the condition. It indicates queue is empty. And now look at this condition. The condition rare equals to n indicates that queue is full. How can we make out whether the queue is full or not? By looking at the rare pointer. Rare pointer is the place where we can insert new data item into the queue. Here, if rare is pointing to n is nothing but size of a queue or length of an array. If these two are equal here, then the queue is full. We cannot insert any new data item into the queue. These two are the conditions to be referred. Here, how we can represent in computer memory. Let us take an example here. In this example, size is 9 and last index is 8. So, at the beginning, friend equals to 1. In this example, rare equals to 4. It indicates that the last element D is inserted at the index 4. Now, friend equals to 1. The friend equals to 1 indicates the first element of a queue. Here we are not considering the index 0 in this example. So this is the first element. So in the queue, first element inserted is A, next B, C, D. So this is an example for or how we represent in computer memory. Now, if you want to insert one more data item into the queue, the logic here is we have to push this rare pointer from here to this point, means from 4 to 5. That is rare equals rare plus 1. The meaning is that now rare is at the pointer 5 in this example. So this is the place where we can add or insert new data item E. So this is the E is the last element inserted, and this is with the logic that rare equal to rare plus 1, means we have to push the rare pointer by plus 1. Next, if you want to insert one more element into queue, again we have to increment the rare pointer by plus 1. Then pointer will come to this point, and this is the place we can insert one more data item. So if you consider this example, value of R rare equals to 5. This is the last element inserted, and front is the pointers or it is at the index 1, it remains same. Now we want to delete an element from the queue, or if you want to remove the element and only the first element inserted, it has to be removed first according to the FIFO principle. So accordingly, if you want to delete one element, that has to be A. So here in this example, we have to push the friend pointer from here to this point. So if a friend pointer, now in this example, at the beginning it is at 1. So this is the element to be deleted. So the item to be deleted is A, and here how logically we have to move the friend pointer by plus 1. So suppose if the friend pointer is at this point now, then it is understood that the element A or data item A is removed from the queue. Now look at the slide here. See, this is the item, the element to be deleted. Here item equal to queue of friend. In this example, item is A, that will be equal to queue of friend. Q is name of the queue, friend is an index. So here in this example, friend index is 1. So Q of 1, that is A. In this example, Q of index 1 is 1, that is A. Item A is deleted. So this is the logic for removing an element from the queue. So here we are using two concepts. One is rare equal to rare plus 1, that is a data item to be inserted. And whenever you say friend equals to friend plus 1, that is the logic to remove the data item at the index friend. This is how we represent queue in computer memory. Now let us move on to next slide. Here this is an algorithm for insertion. Now let us see the algorithm for or the logic for inserting a new data item into the queue. So here algorithm, let Q be the linear array consisting of n elements. Size of an array or size of the queue is n elements. Front is the pointer that contains the location of the element to be deleted, and rear contains the location of the inserted element, and item is the element to be inserted. So now let us see the logic or algorithm for this. Step 1, here if rear equals to n minus 1. Here rear is the pointer where we are going to insert one more element, or it indicates the, or it points to the last element of a queue. Suppose rear pointer equal to n minus 1. What is n minus 1? That is the last index of a queue. Here size is n and last index is n minus 1. So in this example, if rear points to n minus 1, if these two are equal, then it is understood that it is overflow or queue is full. So in that case, we cannot insert new data item, so we have to come out of the queue. Now step 2, if condition fails. So step 2 is if front equals to null, then front equal to 0, rear equal to 0. So what is the meaning of this? Front at the beginning, front equal to null means front is equal to null means 0, then it is an empty queue. So when the queue is empty, front and rear pointer points to 0. Now if you want to insert one more element to this queue, then rear equal to rear plus 1. At the beginning, when the queue is empty, these two are points to 0. And if you want to insert one more data item, we have to push or we have to increment the rear pointer by plus 1. So once if we increment the rear pointer by plus 1, so this is the place where we can insert new data item. So this is the logic or algorithm for insertion operation. Now let us see the algorithm for deletion. What is algorithm for deletion? Here let Q is name of a queue consisting of n elements. N elements, the size of an array or size of the queue, and front is the pointer that contains the location of the element to be deleted. Rear is the pointer, it contains the location of the inserted element. The following, this is the algorithm. It deletes the element at the front position. Now let us see the algorithm. Step 1. Here if front equals to null, as we have seen in the previous algorithm, if front equal to null, then it understood that there are no elements, means the queue is empty. Once the queue is empty, there is no question of removing any element from the queue. So then we have to come out of this algorithm. Next, if front equals to rear, then means if one element. If front equals to rear, front equals to null, rear equals to null. This is at the beginning. This is a condition at the beginning. Else, front equals to front plus 1. As we have seen in the previous example, if we have to increment the front pointer by plus 1, understood that from that point the element is deleted. So front equal to front plus 1. So we have to increment the front pointer by plus 1. So this is logically removes the element from the queue. So then we have to return. So this is an algorithm for deletion operation. Now let us move on to next slide. It is applications of queue. Applications of queue. Here one is simulation. One of the application is simulation, and second application is various features of operating system. Operating system often maintain a queue of processing that are ready to execute or that are waiting for a particular event to occur. So here on operating system, it follows the queue system. Here in any of the operations to be executed, it will be in its own queue. So whichever appears first in the queue, that will be executed, and next operation and so on. That is an example for queue operation or applications of queue. Next one is multi-programming platform systems. It supports multi-programming platform. What is multi-programming here? The CPU, it supports the execution of more than one program simultaneously. In that way, the CPU it allots equal amount of time for all the programming concepts. That is multi-programming. That is also an application of queue. Next one is different type of scheduling algorithm. Here scheduling is nothing but a task. So we can schedule any operation. For example, the shutdown operation, it can be scheduled. So we can set a time, we can schedule that. So we have to shut down the system at so and so time. So in that case, at the same time, it will be the system goes off. That is an example for that. Similarly, we can schedule so many algorithms so that all these schedules will be in a queue. So the first schedule or the task in the queue, it will be executed first. That is scheduling algorithm. Next application is printer server routines. For example, if there are number of computers in an office and with only one printer, in that case, all the users will make use of only one printer, and all the print command or print action from different users are stored in the form of a queue, and whichever the task or whichever the signal comes first, that will be executed first in the queue. That is an example for our applications of queues. Next one is various applications of software is also based on queue data structure. These are all different applications of queue. Students, let us continue our discussion in my next session. Thank you very much.